Here's an uncomfortable question. If the universe decided to end us, how much warning would we actually get? It turns out that's the number that matters most, because for some cosmic threats, we'd have decades, enough time to see it coming, to plan, to act. For others, just hours, barely enough to brace. And for one, the warning literally cannot exist. The danger and the discovery arrive in the very same instant. So we did something simple. We took 6 real cosmic threats and ranked them, not by how frightening they sound, but by the only thing you could ever do anything with: time. The clock starts as big as it gets. Watch it shrink. Number 1, a giant asteroid. And honestly, this is the good news. Here's why. Space is enormous, but we've been watching it carefully. Telescopes sweep the night sky over and over, logging everything that moves. We've now found more than 90% of the truly dangerous ones, the kilometer-sized rocks near Earth, and not a single one is on a collision course. And if that ever changed, we probably wouldn't get days of warning. We'd get years, maybe decades. That's what separates this threat from every other one on the list: time to act. And we've proven we can. In 2022, NASA flew a spacecraft called DART directly into a small asteroid on purpose and measurably changed its orbit. We are the first species in the entire history of this planet that can reach up and move a world. Number 1 is the threat we've already begun to solve. Number 2, a wandering black hole. Most black holes stay where a giant star used to be, but some got kicked loose, flung out by the same violent deaths that created them, and now they drift through the galaxy completely alone, unlit, untethered, invisible. There may be 100 million of them roaming the Milky Way, and here's the unsettling part. If one were drifting toward us, we would not see it coming. There's nothing to see. What we'd see instead are its fingerprints. Comets in the outer solar system nudged off paths they've held for billions of years. Planets easing out of their orbits, by inches at first, then by miles. We'd raid the wobble long before we understood the cause. That could give us years of warning. And in those years, there would be absolutely nothing we could do. You can't deflect a black hole, you can only watch and check the math. So far, the universe has been almost polite. Decades, years, time to think. But now the clock drops from years straight down to hours. Number 3, our own sun. It looks perfectly steady from down here, but it's a churning ball of plasma that occasionally loses its temper. In 1859, it hurled a billion-ton cloud of charged particles directly at Earth, what we now call the Carrington event. When it struck, auroras lit the sky so brightly that people could read newspapers by them at midnight, glowing far closer to the equator than they ever normally reach. Telegraph lines, the internet of their day, sparked and shocked their operators. Some kept working even after the batteries were disconnected. That cloud crossed the 90-odd million miles from the sun to Earth in about 17.5 hours. So that's the warning window, not for the end of the world, but for the end of the world as we run it. 17 hours to protect power grids, satellites, and GPS before a storm like that could cripple the technology a modern civilization depends on. Not extinction, just possibly the most expensive day in human history. Number 4, a nearby star explodes. When a giant star finally runs out of fuel, its core collapses in less than a second, and it detonates as a supernova, briefly outshining an entire galaxy. But here's the strangest part. The first warning wouldn't arrive as light, it would arrive as ghosts. In that collapse, the dying star releases an almost unimaginable flood of neutrinos. Particles so faint, so unwilling to interact with anything, that trillions are passing through your body right now and you feel nothing at all. They slip out of the star slightly ahead of the light. So detectors buried deep underground would start ringing roughly half a day before the sky itself changed. And we know this works, because it already happened. When a star exploded in a neighboring galaxy in 1987, 3 detectors around the world caught its neutrinos about 2 to 3 hours before the light arrived. 12 hours of warning carried by particles that pass through the whole planet as though it isn't there. The good news? No star close enough to truly harm us is anywhere near ready to blow. Betelgeuse, the famous candidate, is far too distant to be dangerous. If it exploded tomorrow, it wouldn't hurt us. It would simply be the greatest light show in human history. 17 hours, 12 hours. Enough time, at least, to say something that matters, but it gets worse, because the last two threats give you no time at all. Number 5. A gamma-ray burst, the most violent explosion the universe knows how to make. When certain giant stars collapse, they don't just blow outward, they fire two narrow beams of pure energy from their poles, focused like the beam of a lighthouse. In just a few seconds, one of these bursts can release more energy than our sun will produce across its entire 10 billion-year lifetime. We only noticed them by accident, on satellites built to watch for nuclear tests during the Cold War, and here's the chilling elegance of it. If a gamma-ray burst within a few thousand light-years were aimed straight at Earth, we would get no warning at all, because the burst travels at the speed of light. Nothing could outrun it to warn us. The warning and the event are the same thing. Some scientists suspect a burst may have thinned Earth's protective ozone and helped trigger a mass extinction more than 400 million years ago. But the odds of one striking us? Vanishingly small. The beams are needle-thin, the galaxy is vast, and no known star is aimed our way. And number 6 is different from everything before it. This isn't an object you could point a telescope at. It's a question about the rules themselves. Everything in nature tends to settle into its lowest, most stable state. The unsettling possibility from particle physics is that the emptiness of space, the vacuum itself, might not actually be in its true lowest state. It might just be resting in a dip. Stable for now, but not forever. If that were true, then somewhere, someday, a tiny bubble of true vacuum could form and expand outward at the speed of light, rewriting the laws of physics inside it as it grows. Atoms, chemistry, everything we're made of, reconfigured into something else entirely. You wouldn't see it coming. You wouldn't feel it arrive. The clock doesn't reach zero. The clock, and the very idea of a clock, simply stops existing. But before you lose any sleep, this one is purely hypothetical. And physicists' honest assessment is that if it can happen at all, the expected wait is so many times longer than the current age of the universe that it isn't a danger, it's a curiosity. So here's the ranking by the only number that counts. Decades for the asteroid, the one threat we can actually fight and already have. Years for the silent drifter we'd know only by its fingerprints. Hours for the sun's bad day and the ghost particle alarm from a dying star. And 0 or less than 0 for the final 2. But here's the honest ending, and it's the part that matters. Not one of these is expected in your lifetime, or your children's, or your species' near future. The universe isn't out to get us. It's mostly just enormous and old and very quiet. It simply doesn't send calendar invites. If this made you look up at the sky a little differently tonight, subscribe to Stellar Decoded. We turn the universe's biggest questions into 10 quiet minutes that actually make sense. And if you want the cosmic mysteries science still can't explain, that video is right here. Thanks for watching.